Light, quite literally, is nourishment for your eyes. It's not just about vision, it's about biology, neurochemistry, and long-term health. Every time light enters your eyes, it's doing more than letting you see. It's influencing the rhythms of your entire brain and body. Morning sunlight exposure, in particular, serves as a powerful synchronizer for your circadian clock. And it begins with the retina. Inside the eye, there are specific retinal ganglion cells that are directly sensitive to light, not for the purpose of forming images, but for setting your internal timing systems. These cells communicate with a region in your hypothalamus called the suprachiasmatic nucleus, or ASEAN, which acts as the master clock of your body. When these cells are activated by morning sunlight, they trigger the release of cortisol, a hormone often misunderstood as merely a stress molecule, but which plays a vital role in promoting alertness, enhancing immune function, and reinforcing the wake cycle. This cortisol pulse early in the day, prompted by natural light exposure, is not a bad thing. In fact, it's exactly what primes your body and brain for optimal performance. It also sets a timer for the release of melatonin about 14 to 16 hours later, which means the light you get in the morning determines how well you'll sleep at night. In modern life, this system is disrupted. Most people wake up in dim indoor lighting, then spend their day under fluorescent bulbs and LED screens, and then expose their eyes to bright artificial light well into the evening. The result is confusion in the visual and circadian systems. These unnatural light patterns desensitize the light-sensitive retinal ganglion cells and suppress the healthy cortisol spike in the morning, delaying melatonin release and distorting the sleep-wake cycle. Over time, this contributes not just to poor sleep, but to systemic stress, fatigue, cognitive fog, and ocular strain. Moreover, long-term deviation from natural light rhythms is associated with increased risk of myopia, especially in children and adolescents. Studies have consistently shown that children who spend more time outdoors have a significantly lower incidence of nearsightedness. Their reason: the full spectrum of sunlight stimulates proper eye development, and the exposure to far-field vision looking into the distance trains the eye muscles and lens system to adjust naturally. Indoor environments, by contrast, demand constant near-field focusing, which over time alters the shape of the eye, promoting elongation that leads to myopia. One of the most actionable things you can do for your eyesight is to get outside within 30 to 60 minutes of waking. Aim for 5 to 10 minutes of direct sunlight if it's bright out, or 15 to 20 minutes on cloudy days. Glass windows don't count. You need to be outside because most indoor light levels are 50 to 100 times dimmer than what's needed to trigger those retinal pathways. When you're outdoors, don't stare directly at the sun. Instead, allow ambient light to enter your eyes from the environment. You can look at the sky, the horizon, or anything that allows light to be absorbed passively. Over time, this practice reinforces your natural sleep-wake rhythm, lowers evening cortisol, enhances mood through dopamine and serotonin pathways, and improves visual focus and acuity. Another issue with artificial lighting, especially blue and rich LED light at night, is its direct impact on melatonin suppression. Melatonin is not just a sleep hormone, it's a powerful antioxidant and a neuroprotective agent. Chronic suppression of melatonin has been linked to a variety of health issues, including accelerated aging of retinal tissue and impaired mitochondrial function in the eye. In other words, evening screen exposure doesn't just interfere with sleep, it may actually age your eyes. To counter this, dim the lights in your environment about 2 hours before bedtime and minimize exposure to screens. If you must use screens, consider using night mode, blue blocking filters, or ideally, blue blocking glasses. But the key idea here is to respect the evolutionary biology of the eye. Your retina was not designed for backlit screens and overhead LED at midnight. It was designed for dawn and dusk, for soft shadows and broad spectrum light that changes throughout the day. Another fascinating dimension of light exposure is its role in mood regulation and cognitive performance. The same retinal ganglion cells that respond to sunlight also communicate with brain areas involved in mood, such as the amygdala and prefrontal cortex. Studies have shown that insufficient morning light exposure is correlated with increased risk of depression, seasonal affective disorder, and cognitive sluggishness. By contrast, individuals who receive sufficient natural light in the first half of the day report better mood, sharper focus, and greater motivation. This neurobiological link between light and mood means that taking care of your eyes through proper light exposure is not just a matter of avoiding glasses or reducing strain. It's a form of mental hygiene. You're giving your visual system the raw input it needs to regulate not just how you see the world, but how you feel about it. The bottom line is this: light is a nutrient, and your eyes are the entry point for it. Treat it with the same level of importance as food, movement, or sleep. Begin your day with sunlight, avoid unnecessary artificial light at night, and recognize that your visual system is always training either toward better function or toward deterioration, depending on what you feed it. By aligning your light exposure with the natural rhythms your biology expects, you're not just improving your eyesight, you're supporting your entire neurological framework for wellness and high performance. Visual anchoring is one of the most overlooked yet powerful strategies to preserve and improve your eyesight in the modern world. At the center of this practice is a principle known as the 20-20-20 rule. Every 20 minutes of near work, such as reading, writing, or looking at a screen, you take a 20-second break and look at something 20 feet away. On the surface, this may seem like a simple productivity tip, but underneath it lies deep neuroscience about how the eye's internal muscles function and how visual fatigue builds up throughout the day. When you're working on a computer or using your phone, your eye muscles, particularly the ciliary muscles, are in a state of constant contraction. These muscles are responsible for adjusting the shape of your lens to help you focus on objects at close distances, a process known as accommodation. Unlike skeletal muscles that contract and relax rhythmically during physical movement, these tiny eye muscles can remain tensed for hours if you're not deliberately shifting your gaze into distance. Over time, this sustained contraction leads to muscle fatigue, headaches, and a phenomenon known as digital eye strain, or computer vision syndrome. Symptoms may include blurry vision, dry eyes, burning sensations, and even double vision. Now, what's fascinating from a neurological standpoint is that when we focus on something far away, the ciliary muscles relax. This is a physiological rest state for the eye. Looking into the distance is not just a break for your focus. It's an actual neuromuscular reset that helps maintain the eye's ability to adjust between distances, a process known as dynamic accommodation. Just like we don't expect our biceps to be contracted all day long without consequences, we shouldn't expect our eye muscles to remain in a constant near-focus state without degradation in function. Beyond muscle fatigue, there's also the issue of attention anchoring. When you're looking at a screen, not only are your eyes fixed in one position, but your attentional circuits are locked in a narrow, repetitive focus. This repetitive visual input can reduce cortical excitability in regions of the brain associated with broader spatial awareness and visual attention. In other words, extended near-focus activity without breaks can diminish your ability to shift focus, to process peripheral cues, and even to react quickly to changes in your environment. Over time, this limits your visual plasticity, the brain's ability to adapt and improve in processing visual information. Implementing the 20-20-20 rule isn't just about comfort. It's about preserving your visual performance in the long term. Every time you shift your gaze into the distance, you're exercising the full range of your visual system. You're reminding your eyes how to coordinate between short and long range focus. You're activating retinal cells that don't get much stimulation during close-up work, particularly those responsible for peripheral and depth vision. And you're preventing your visual processing from becoming overly narrow, which has implications not just for eyesight, but for cognitive flexibility and situational awareness. Another factor to consider is blink rate. When we're using screens, our blink rate drops significantly, sometimes by 50% or more. This leads to tear film instability and dry eyes, which further contributes to discomfort and blurry vision. During these 20-second breaks, consciously blinking and allowing your eyes to relubricate can have a profound impact on visual clarity. Even better is if you take those 20 seconds to look out a window, preferably at a tree, a skyline, or any natural object far in the distance. The irregular contours and depth of natural scenes engage a broader range of photoreceptors and visual pathways, leading to richer stimulation of the visual cortex compared to flat digital imagery. For individuals who perform extensive near work, especially students, software developers, designers, and office workers, I often recommend taking these visual resets even further. Every 2 hours, take a 5-minute break to not just look far away, but to move your eyes around. Track a moving object, shift your gaze from near to far repeatedly, or simply go for a short walk and allow your visual attention to soften and widen. These exercises recalibrate the lens system, reactivate peripheral vision circuits, and help you maintain the neuroplastic flexibility of your visual system. One of the most promising areas of research now looks at how these periodic resets affect not only ocular health, but also productivity and mood. Visual fatigue doesn't just impact eyesight. It affects how we think, feel, and perform. People who regularly use visual breaks report higher concentration levels, reduced anxiety, and even fewer musculoskeletal complaints like neck or shoulder tension. That's because your eyes are intimately linked to the vestibular and postural systems. When your eyes are strained, your posture often follows, creating a chain reaction of discomfort. The takeaway is this: your visual system thrives on variety. The more you alternate between near and far vision, the more you allow your eye muscles to relax and reset, and the more resilient your vision becomes. This isn't a luxury, it's a biological necessity, especially in a world where digital interfaces dominate our days. Visual anchoring through techniques like the 20-20-20 rule is a fundamental tool in preserving not just your ability to see clearly, but your overall brain performance, physical comfort, and long-term neurological health. Make these resets part of your daily rhythm, and your eyes will thank you for years to come. Most people today are unknowingly training their visual system to be near, sighted both literally and neurologically. The modern environment has shifted the visual demand toward close, range tasks, scrolling on a phone, typing on a laptop, reading from a tablet, even indoor living with walls just feet away. This has created a near-vision dominant visual behavior that understimulates two crucial aspects of eyesight: depth perception and peripheral awareness. These are not passive visual functions. They are active skills that rely on specific circuits in the brain and muscles around the eyes. When underused, they weaken. When trained, they adapt and strengthen. Vision is not fixed. It's a dynamic skill shaped by daily behavior, and one of the most powerful yet underutilized ways to improve it is by deliberately engaging the systems responsible for seeing. Distance and processing periphery. Depth perception is your brain's ability to interpret how far away objects are. It relies on binocular vision, both eyes working in coordination to focus on an object and interpret spatial cues from slightly different angles. But when we spend the majority of our time looking at objects only inches from our face, we suppress that system. Over time, this can cause convergence problems, where the eyes fail to work together effectively. It also dulls the brain's sensitivity to spatial distance, which affects not only eyesight, but also coordination, balance, and reaction speed. Peripheral vision, meanwhile, is your ability to sense movement and visual detail at the edges of your visual field. It's crucial for detecting threats, maintaining spatial orientation, and enhancing situational awareness. But our constant fixation on small screens trains us to live in a tunnel of vision, narrow, focused, and central. This suppresses the lateral processing of the retina and starves the brain regions responsible for peripheral alertness. It's like going to the gym but only training your right bicep. Eventually, the rest of your body weakens from disuse. The same principle applies to vision. To counteract this imbalance and restore the full spectrum of visual capability, you need to intentionally train the systems that support distance and peripheral processing. One of the simplest and most powerful ways to do this is to spend time in wide-open environments. Natural landscapes, hills, parks, beaches, long roads, open fields stimulate the far vision system by demanding your eyes adjust and focus across multiple planes. This engages the lens system in your eyes to shift between distances, activating both the ciliary muscles and the cortical circuits responsible for interpreting spatial layout. 10 to 20 minutes of walking in such an environment while keeping your gaze soft and scanning the horizon helps re-establish natural eye movement patterns. It encourages your brain to re-engage spatial mapping processes, strengthening not just eyesight, but also posture, balance, and even decision-making speed. Peripheral training can be introduced with conscious exercises. One of the most accessible is gaze expansion. Stand still and fix your eyes on a central point in front of you. Don't move your head. Now, without shifting your gaze, begin to pay attention to what you can see at the edges of your vision. Notice motion, colors, shapes on the sides. You're activating what's called the magnocellular pathway, which is crucial for motion detection and situational awareness. This neural pathway has strong links to attention and stress regulation. When it's understimulated, the brain tends to become hyper, focused, and easily overwhelmed. But when trained, it creates a calm, wide field of visual processing that helps you feel more grounded and responsive in real time. A more advanced practice involves alternating between near and far focus in deliberate intervals. Take an object like a pen and hold it at arm's length. Focus on the tip of the pen for 3 to 5 seconds. Then immediately shift your gaze to a distant object 15 to 20 feet away. Repeat this 10 to 20 times. What you're doing is engaging the full accommodative range of the eye, forcing it to rapidly refocus and adjust between two distances. This trains both the lens and the muscles around your eye to become more flexible and responsive. Done daily, this simple drill helps maintain the elasticity of your focus system and strengthens depth processing. Another exercise uses eye tracking patterns. Take a small ball, like a tennis ball, and slowly move it in figure, rate, or circular patterns in front of your eyes. Follow it with your gaze while keeping your head still. This enhances ocular motor control and fine-tunes the coordination between eye movements and brain perception. Add variety by sometimes using two hands and shifting focus between them. You're not just training the eyes, you're syncing multiple brain regions that interpret motion, direction, and visual attention. What's critical to understand is that these exercises are not replacements for healthy behavior. They are supplements. The foundation of strong vision still lies in your environment. If your lifestyle continues to place 95% of visual demand on close screens in confined spaces, no amount of exercise can undo the cumulative strain. That's why one of the best things you can do is simply spend more time outdoors. Outdoor vision provides full spectrum light, depth cues, horizon scanning, and moving peripheral stimuli, all of which rejuvenate the visual system and train it in its native setting. In summary, your eyes and brain thrive on visual diversity. They need distance, movement, variety, and peripheral stimulation to stay sharp and responsive. Near vision dominance is an artificial habit created by modern tools, not a biological default. By introducing intentional practices that train depth and peripheral vision, you're not just preventing deterioration. You're actively upgrading the performance of your visual system. You're making your eyes more adaptive, your brain more alert, and your body more responsive to the world around you. And the best part is, this improvement is accessible. It doesn't require expensive tools, just conscious effort and a commitment to letting your visual system operate the way nature designed it to. Your eyes are extensions of your brain. The retina, which lines the back of the eye, is actually neural tissue. It contains photoreceptor cells that convert light into electrical signals sent directly to the brain. And like any other part of the nervous system, this structure depends heavily on specific nutrients to function properly, repair itself, and resist degeneration. When people think about eyesight, they often overlook the role of nutrition. But the truth is, what you put on your plate directly impacts the health, longevity, and performance of your visual system. One of the most critical nutrients for eye health is vitamin A. It plays an essential role in the production of rhodopsin, a light, sensitive pigment found in the rods of the retina. Without sufficient vitamin A, your ability to see in low light deteriorates, and in severe cases, it can lead to night blindness. This isn't just a concern for people in developing countries. Mild deficiencies are surprisingly common in industrialized societies, particularly among people who consume diets low in colorful vegetables and high in processed foods. Carrots, sweet potatoes, dark leafy greens, and liver are rich sources of preformed or provitam, in compounds that nourish the retina and keep vision functional in all lighting conditions. Another crucial set of nutrients is the carotenoids, especially lutein and zeaxanthin. These pigments are found in high concentrations in the macula, the central part of the retina responsible for sharp, detailed vision. They act as natural antioxidants and blue light filters, absorbing harmful wavelengths before they can damage the photoreceptor cells. Without enough of these pigments, the retina is more vulnerable to oxidative stress, especially in an age of constant exposure to screens and artificial lighting. Over time, this can lead to a gradual degradation of central vision and a higher risk of conditions like macular degeneration. What's fascinating is that the body doesn't synthesize lutein or zeaxanthin. You must get them through diet. Leafy greens like kale, spinach, and collard greens are excellent sources. Egg yolks also contain bioavailable forms of these carotenoids, making them a valuable addition to a vision-supportive diet. Omega-3 fatty acids, particularly DHA-DOCUS, hexenoic acid, are another foundational component of eye health. DHA is a major structural fat in the retina, especially in the photoreceptor membranes. It supports the fluidity and function of these cells, facilitating faster and more precise visual signal transmission. Deficiency in DHA has been linked to dry eye syndrome, retinal thinning, and even early onset visual decline. Cold water fish like salmon, sardines, and mackerel are rich in DHA, and for those following plant-based diets, algae oil supplements can provide a direct source. The standard Western diet is often high in omega-6 fatty acids, which can be inflammatory when not balanced with sufficient omega-3 intake. This imbalance is not only a risk to cardiovascular health, it also silently erodes the resilience of your visual system. Another key component of ocular nutrition is zinc. This mineral is heavily concentrated in the retina and plays a role in the metabolism of vitamin A, as well as in enzymatic reactions that maintain visual signaling pathways. Low levels of zinc have been associated with poor night vision and increased risk of age-related visual disorders. Foods like pumpkin seeds, oysters, beef, and chickpeas offer a strong zinc supply. What's important here is that zinc also acts as an antioxidant, countering the effects of oxidative damage that accumulates over time, especially in the retinal pigment epithelium, which is essential for photoreceptor renewal. In addition to these core nutrients, there is a growing interest in astaxanthin, a potent antioxidant found in algae and seafood like krill and salmon. Unlike many antioxidants, astaxanthin can cross both the blood-retinal and blood-brain barriers, allowing it to directly reduce inflammation and oxidative stress within the eye. Clinical research suggests that astaxanthin may improve retinal blood flow and reduce symptoms of digital eye strain, especially relevant for those who spend hours each day staring at screens. And then there's the metabolic factor. The retina is one of the most energy-demanding tissues in the human body. It requires a steady supply of glucose and oxygen to sustain phototransduction, the process by which light is converted into electrical signals. But excess glucose, as seen in individuals with poorly controlled blood sugar or insulin resistance, can damage small blood vessels in the retina and lead to a condition called diabetic retinopathy. This is one of the leading causes of blindness in adults. Therefore, regulating blood sugar through a low-glycemic, nutrient-dense diet is essential not just for metabolic health, but also for preserving the microvascular integrity of the visual system. Hydration also plays an underrated role in vision. The tear film that coats the front of the eye is composed of water, lipids, and mucins that protect the cornea, keep it smooth, and help with light refraction. Chronic dehydration or electrolyte imbalances can disrupt tear production, leading to dry eyes, blurry vision, and a feeling of grittiness. Staying well, hydrated, and consuming sufficient electrolytes, especially sodium, potassium, and magnesium, helps maintain ocular surface integrity and overall eye comfort. In a world saturated with quick, fix solutions, eye drops, glasses, blue light filters, people often forget that long-term visual health begins from within. The retina, macula, and optic nerve are living tissues, and like any part of the body, they need specific building blocks to thrive. By consistently fueling your system with the right nutrients through real, unprocessed, color-rich foods, you're giving your eyes the biochemical tools they need not just to function, but to adapt, regenerate, and perform at a high level for years to come. Improving your eyesight is not only about what you avoid, but about what you consistently supply your body. When it comes to vision, nutrition is not just preventive, it's transformative.